Hello, 5th grade. Welcome to a new week. Today we're going to be talking about something in chemistry called limiting reactants. And this is something that has to do with chemical reactions, which we've been talking about the last few weeks. So, if you remember, this is kind of a general form of what a chemical equation looks like. You start with something, and then you end with something different. So here we're starting with A plus B. Those are our two reactants. And when they react together, we are given C plus D is what we end up with. Now, I could also give you a specific formula. So here is an equation for how to make water. We're combining one oxygen molecule, so one O2, plus two hydrogen molecules, so two H2, and we're getting two water molecules at the end. Remember, we have the little 2's next to the O and the H because they naturally exist like that. Oxygen and hydrogen like to have a buddy atom with them, so you always find them in 2's out in nature. Now, in both of these equations, the items that are red are the reactants, and the items that are green are the products. And this is something we've talked about before, but it's going to be important for today, because we're going to be using these terms a lot. So I want to make sure you know what reactants are and what products are. Reactants are what you start with, and products are what you end with. Another way of putting it is that reactants are what react together, and products are what you produce at the end. If you kind of look at the words there, you have react and produce in those words. So our reactants are oxygen and hydrogen, and our products are water in this case. You can have one or multiple products. It just depends on the equation, the type of reaction that you're doing. So, how I want to introduce this concept for you today is with sandwiches. So let's make some sandwiches, and these are going to be delicious bacon and cheese sandwiches. I don't know if you ever eat bacon and cheese sandwiches, but I'm going to pretend that you do, and that's what we're going to have today. So let's say that for every sandwich that we're going to make, we're going to need 2 slices of bread, 1 slice of cheese, and 4 pieces of bacon. That is like the formula for a bacon and cheese sandwich. You need the 2 pieces of bread for the bun, 1 slice of cheese, and 4 bacon because we like bacon. Now, let's say then that we have 16 slices of bread. So we have like a loaf of bread, 16 slices, pretty good. We have 10,000 slices of cheese. You know, our dad works at a cheese factory or something. We have 4 pieces of bacon, just maybe left over from breakfast today. So we have 16 slices of bread, 10,000 slices of cheese, and 4 pieces of bacon. My question for you is, how many sandwiches can we make using these ingredients? Now, these sandwiches have to follow the formula of 2 pieces of bread, 1 slice of cheese, and 4 pieces of bacon. We can't have 1 piece of bread and 1 piece of bacon. That wouldn't be a proper sandwich. We have to keep these proper sandwiches. So how many sandwiches can you make? Now, when you first look at this, you might think, oh, if we only need 1 slice of cheese per sandwich, and we have 10,000 slices of cheese, we can make 10,000 sandwiches. And if you had an infinite supply of bacon and bread, wouldn't that be nice? If you had an infinite supply of bacon and bread, then you could do that. But the problem is, you're actually going to run out of either bacon or bread before you make your 10,000 sandwiches using your 10,000 slices of cheese. So they're going to limit how many sandwiches we can make. And so let's go and look at the 4 pieces of bacon and the 16 slices of bread. So 16 slices of bread, if we're using 2 slices of bread for every sandwich, we'd be able to make 8 sandwiches using that bread. Okay, that's enough to feed a family. But then if we look at our 4 pieces of bacon, how many sandwiches can we make with 4 pieces of bacon? Well, if it takes 4 pieces of bacon per sandwich, and we have 4 pieces of bacon, we can only make 1 sandwich using those 4 pieces of bacon. And so how many sandwiches can we make? We can only make a single sandwich, just 1 sandwich. And that is because we're running out of bacon before we run out of bread or cheese. So it limits how many sandwiches we can make. So let's do this exercise again. But we have the same formula for a sandwich: 2 slices of bread, 1 slice of cheese, 4 pieces of bacon. But let's pretend that instead of just 4 pieces of bacon, we have now, I guess, found a herd of pigs and turned it all into bacon, and we have 4,000 pieces of bacon. So we have 16 slices of bread still, 10,000 slices of cheese still, and now we have 4,000 pieces of bacon, making us very happy. How many sandwiches can we make now? So, Once again, you might think, oh, 10,000 slices of cheese. We have more bacon this time, so we can make more sandwiches. So we can make 10,000 sandwiches now. Unfortunately, it doesn't quite work that way, because if it takes 4 pieces of bacon per sandwich, and we have 4,000 pieces of bacon, we can only make 1,000 sandwiches, because that would use up all 4,000 pieces of bacon. So you might think, okay, we can only make 1,000 sandwiches. Still pretty good, bacon and cheese sandwiches. But then you look at your 16 slices of bread and you wait, oh, we're going to run out of bread before we run out of bacon or cheese. So at this point, because we've increased the number of bacon, we are going to run out of bread before we run out of anything else. So 16 slices of bread, remember, is only enough to make 8 sandwiches, because they each take 2 slices. So if we make 8 sandwiches, we're going to have plenty of cheese for that. We're only going to use 8 slices of cheese. And we're only going to use 32 pieces of bacon, but that's all the sandwiches that we can make. So we can only make 8 sandwiches using these materials that we have this time. So in this case, you notice the bacon didn't run out first, but the bread did. So the bread limited how much of the sandwich we were allowed to make. And I guess maybe if you really wanted to get creative, you could use cheese as both the buns and the cheese. So you have 3 pieces of cheese and 4 pieces of bacon. Sounds pretty good. Don't know about you, but anyways, yeah, so we can make 8 sandwiches given these materials. So we can almost write this as a chemical formula. So in a chemical equation, we have 2 breads plus 1 cheese plus 4 bacons give us a sandwich. And I can kind of compare this to the equation that we saw earlier with oxygen and hydrogen mixing to give us water. Notice the red terms are the reactants, and the green is the product. So the sandwich is the product in our kind of formula or equation for the sandwiches, and the bread, cheese, and bacon, the ingredients, are the reactants. So as I demonstrated with the sandwiches, sometimes if we have much more of some of the reactants than the other reactants, so if we're on short supply of one of the reactants, that one limits how much of the product we can make. And this gives us the idea of a limiting reactant. So notice the name of limiting reactant. It is a reactant that is limiting. It limits what you can do. So limiting reactant is the reactant that runs out first, thus limiting the amount of product that you can make. So in our first example, when we only had 4 pieces of bacon, that was the limiting reactant, because we could only make 1 sandwich. And in the second one, when we had 16 slices of bread, that was limiting reactant, because it only enabled us to make 8 sandwiches. So this applies to chemical formulas as well. So when you are doing a chemical equation and you want to figure out how much you can make of something, you have to consider how much of your starting reactants you have, and that'll tell you how much of your final product you can make. And you can extend this principle to a lot of things beyond just chemistry, like baking. It works very well for baking. If you want to make chocolate chip cookies and you need 100 chocolate chips per few cups of flour or whatever, you can figure out how many cookies you can actually make using the reactants or the ingredients that you have. So there's lots of useful ways to think about limiting reactants beyond just chemistry. So let's consider then that equation again, our oxygen molecule plus 2 hydrogen molecules giving us H2O. And I want to think in terms of limiting reactants in terms of chemicals now as opposed to ingredients. So let's say we have 15 of these oxygen molecules and 10 of these H2 molecules, the hydrogen molecules. How many H2O molecules, that is water, can we make? So if you need to pause the video and try and figure that out, go ahead and do that, and I'm going to go ahead and explain how to figure this out. What we want to do is we want to see if we had 15 oxygen molecules and unlimited hydrogen molecules, how many water molecules could we make? Or, on the other side, if we had 10 hydrogen molecules and unlimited oxygen molecules, how many water molecules could we make? And we see which one would make fewer water molecules. So if oxygen is going to be able to make, let's say, 2 water molecules and hydrogen is able to make 3, oxygen would be the limiting reactant because it only lets you make 2. So let's reason through this a little bit. If we look at our oxygen molecules, we have 15 O2 molecules. We know that every water molecule has a single oxygen in it. So if we have 15 O2s, if you remember how to do the manipulate your little numbers and everything, you find that we actually have 30 oxygens right here. And if there's 1 oxygen per water molecule, we can make 30 water molecules. So we can make 30 H2Os given our 15 O2s. Likewise, we could do that same point of reasoning for the hydrogens. If we have 10 H2s, that gives us 20 hydrogens total. And every water molecule uses 2 hydrogens, so that would give us 10 water molecules with our 10 H2s. Excuse me, had a sneeze come on. So, what we have to do is, the amount of oxygen that we have lets us make 30 waters, and the amount of hydrogen we have lets us make 10 waters. So how many are we going to be able to make? Is it going to be 30 or 10? Some of you might say, oh, let's do 30 because that's more. But we're going to run out of hydrogens after we make 10 waters. So after we make 10 water molecules, we're going to run out of hydrogen, and we're not going to have any more to make more molecules. So then hydrogen becomes the limiting reactant. And you can do this for any chemical equation. You can look at your reactants and your products and see how many you need of each of the reactants to get your products, and see which one will run out first, and that is your limiting reactant. So that is all that I have for this lesson right here. I did want to show you real quick just one demonstration, and this is exactly what we did in our last class when we learned about combustion, when I showed you putting a jar, like a little candle in a jar, and then putting the lid on it. So, if you remember, fire needs several different ingredients in order to keep burning. That combustion reaction needs several ingredients. And those ingredients are oxygen, a fuel source, and a source of heat. Right now, I already have the source of heat in there. I already have a little flame lit. So all it needs is fuel and oxygen. And as long as it has both of those reactants, this reaction will continue to burn. So it has plenty of wax. You can see in here there's a lot of wax. So it has lots of fuel and has lots of oxygen right now. And so that's why this reaction just keeps going, because there's nothing limiting it. It has all the oxygen in the world to pull from right now. And it has a whole jar of wax to pull from. So it's not going to be running out of anytime soon. So what I could do is I could put the lid on here, and suddenly once I do that, I don't change the amount of wax that the fire has access to, but I do change the amount of oxygen that it has access to. Once I put the lid on, it no longer can reach the oxygen from the rest of the world. It only has a little bit of oxygen that's in the jar. And what ends up happening then is the oxygen becomes the limiting reactant. And so the fire will burn as long as it can, but then pretty soon it's going to use up all of its oxygen, and it won't burn anymore. So little did you know that little demonstration from the end of last class also applies to this class, to limiting reactants. So what I'm going to do, put the lid on, and you'll see the flame starts to get smaller, and then it went out because it ran out of oxygen. So right now there's no more oxygen left in here for the fire to burn. Okay, well that is all that I have for class right now. Hope you enjoyed this lesson, and I'm thinking we'll probably do something of an experiment or a demonstration with this property of chemical reactions later this week, so you can look forward to that. Alright, until then, see ya.